All right, so I know everybody should be enrolled on the Python Essentials course, right? And both the Linux and Introduction to Cybersecurity. So these are and operating system basics. So this one is the criteria for the Cybersecurity Essentials course. So the experts have said that if those that have not completed this particular one will not have access to the Cybersecurity Essentials course, because Cybersecurity Essentials course is going to take you through everything you need to learn to become a junior cybersecurity analyst, and the experts are not ready to waste their time training people that are unserious. So only those serious ones will graduate to the next level. But nonetheless, everybody still has access to the Linux course. At least you'll be able to learn a few things about Linux and the PowerShell or the command line. So today we're looking at Python Essentials. So there are two Python Essentials courses. So there's Python Essentials 1 and Python Essentials 2. Well, we're starting with Python Essentials 1. So the good part is that you get to be able to take PCEP certificate exam. So this one is globally recognized. When you complete this first final exam, you're going to get the digital credential and certificates, which you can post on LinkedIn. But this other one is a different one entirely. So now this is from NetAcad. This one is from the Python Institute itself, PCEP, right? There are two of them, the one for the Essentials 1 and the one for the Essentials 2 course. So you can see that it is locked and you won't have access to it until we are done with this course. Just going to be taking everybody through a tour, first of all, on the platform before we start the course. So this is where all the course information is by the time you open it. So you can see the certification pathway. So we have the entry, we have professional. Also, Cisco WebEx is available here. We are actually using Cisco WebEx for our classes. So we have Python Essentials 1. Everything you chat on this platform, every other student will be able to see it. So you can chat with other students here. You can even tag them if you want. If you know somebody, you can tag them, right? That's for the Cisco WebEx. Then you don't necessarily need to have Python installed on your system to be able to practice, all right? Or you don't need to have a console or IDE installed on your system to be able to practice. When you get to this part, you can actually learn or see how you can install Python. But from the module 2, you're going to see the console for you to practice. So you can type in anything, and I can choose to run my code by clicking on play here, and it's going to run. You can see hello world. So which means that if you're going to use your mobile phone, you can still practice, right? So for those persons who don't have access to a laptop at the moment, they can use their phones to practice, which is actually cool. So they don't get to lose out. So I think that's all for this platform. We're just going to jump right into course. All right. So Essentials 1. So we're going to learn the foundations of computer programming, how computer works, how the program is executed, how Python programming language is defined and constructed. Just give me a minute. And we'll look at the difference between compilation and interpretation, and what Python is, how it's positioned among other programming languages, and what distinguishes different versions of Python. So how does a computer program work? So a program is actually what makes a computer usable, right? So without a computer having been programmed or having a program, you cannot use a computer for anything. So just like you have a piano, right? And you have the person playing the piano. So when the piano is just there and there's nobody to play it, it's just a piano and it's actually useless. So right here, they are telling us that the computer without its program is just a container. So computers have developed over time, right? So some of them could perform just basic arithmetic operations, but now computers can perform very, very complex mathematical equations or mathematical operations. So, for example, now a computer cannot understand the value of a complicated mathematical function by itself, although it is not beyond the realm of possibility. It's possible for computers to understand that. So I'm just going to give you an example. For example, you want to calculate a distance from point A to point B. Computer, please, what's the distance between this place? Distance from here to here. Computer might not understand that. But now, with you outlining some kind of attributes, a computer will be able to give you that particular answer that you're looking for. So you're going to see how to even use Python to do that. So you have to define some things. You have to define some variables. Just like a math, you have variables. All right. You can define variables in Python programming. So let's look at that program again. So imagine you want to know the average speed you reach during a long journey. Okay, you know the distance, you know the time, but you need the speed. And in physics, the speed in physics is actually distance over time, right? That's the normal formula for calculating speed. So if you ask the computer and you don't tell the computer how to calculate speed, it cannot give you a proper answer. So for the computer to give you the answer, it has to accept a number representing the distance and accept a number representing time or the travel time. So when it divides the distance by the time, it's going to give you a result which is going to be interpreted at your speed. So let's look at natural languages versus programming languages. So a language is actually what we use to express our thoughts, what we use to communicate between each other. So, but a machine does not understand the language that we speak as human beings, doesn't understand our own cognitive language. What a machine understands is zeros and ones, and that language is called machine language. So no matter how sophisticated a computer is, and how you think that you are typing something or you're using AI or you're using Alexa, speaking to Alexa, and Alexa is understanding what you're saying. What Alexa understands is machine language, right? It's zeros and one, not your English. So everything that you're saying is being interpreted and transformed into zeros and one before Alexa is able to compute or calculate or give you response to questions that you answer or things that you say. A computer, even the most technical sophisticated computer, is devoid of even a trace of intelligence. We would say that it is like a well-trained dog. So it responds only to a predetermined set of known commands. So you can see there. So the command is recognized as very simple. You can imagine that the computer responds to orders like take that number, divide it by another, and save the results. Now, a set of these known commands that a computer is going to use to give you results is called instructor list. Please take note of the keywords. So IL is instructor list. You might see IL again when you're reading the course. So just know it means instructor list, instruction list. So different types of computers may vary depending on the size of their instruction. Instructions could be completely different in different models. And know that machine languages are developed by humans. So no computer is currently capable of creating a new language. However, that may change soon, just because people use a number of very different languages. Machines have many different languages too. That's, we have Python, right? We have Java. Those are different programming languages that we know. So these are still evolving though, and new words are created every day, even in our natural languages, right? In English, that's why you see when you're using dictionary, you're seeing edition this, edition that of the English dictionary. So the dictionary, new words are being added to the dictionary yearly, daily, right? As English is being modified, as English evolves. So as our natural languages are, more words are being added. But now, what makes up a language? Four things make up a language, right? Any English that you speak at, or any language that you speak, whether it be your mother tongue or a borrowed tongue, right? A borrowed language. Every language has an alphabet, right? Which is a set of symbols, all right, that are used to build words. Okay. It also every language has a lexis. A lexis is a dictionary, right? Which is a set of words and how those words are being used, and also the meaning of those words. Then every language has a syntax, and that syntax is a set of rules that is used to determine if a particular string of words actually makes sense. For example, I am a Python makes sense, but you cannot say I Python A or I am Python A. It does not make any sense. That's because we have to follow syntax. Then every language has semantics. So semantics are a certain phrase makes sense. The first one is different. You say a string of words forms a valid sentence. Second one is whether a phrase makes sense. For example, I ate donuts. You cannot say a donut ate me. Those are two different words that one makes sense and the other does not. So the instruction list is in fact the alphabet of a machine language. So this is the simplest and most primary set of symbols we can use to give commands to a computer. All right, so for a computer to understand, or for a programmer, okay, or a human being to easily communicate with computers, all right, we make use of high-level languages, all right, or high-level programming languages. Now, is this high-level programming languages that are being compiled or interpreted into machine language, which the computer will now understand. So high-level language is the one that we as human beings, it's easier for us to understand. Not that you cannot understand machine language. Don't forget, it's a human being that wrote machine language, right? So which are zeros and one. Only that it will be much more tedious for you to be writing some things in machine language. Imagine if for every alphabet you have to convert everything to 0 and 1 because you want to write something in computer. So where in binary, right? That's what computer understands, 0, 1. And we have, from 0 to 1,000, 1 million. When you're not getting to A, those kind of things, you now start using binary to represent all alphabets. Do you know how hectic that can be? So that's how computers actually understand code or what we are saying. So these high-level languages are somehow similar to our natural language because they use the normal symbols and words that are what we know. All right. So this enables us to express to computers that are much more complex than those that are offered in the instruction lists. So this high-level language, when you've written them, is called what? Source code. So when you write a program, a Python program, that program you have written is called the source code. So now the file that is containing that source code is called a source file. So when you want to pass, just like when you want to install an app or you want to send an app to someone, you now send the application to somebody on Zen. The person will now have to click on that application in order to install it. So that application the person is clicking is actually the source file that contains the source code that gives you the ability to install that program. Now, let's look at compilation versus interpretation. Compilation now in computer is when, then for example, you write an application, okay, you are completely built an application, all right, you now compile it. After an application has been compiled, all right, it can be given to any other person or any other computer to run that application, and the computer will not need to have the compiler that was used to compile the application. For example, when you install Facebook on your phone or install WhatsApp, WhatsApp was programmed with a programming language. Guess what? The programming language that was used, or the compiler that was used to compile WhatsApp, is not existing on your phone for your phone to be able to understand or install WhatsApp. It just runs WhatsApp on its own. That's because the application has been compiled. So for say computer programming is the act of composing the selected programming language elements in the order that will cause desired effect. So the effects could be different in every specific case. It's also programmer's imagination, knowledge, and experience. And of course, the composition has to be correct in many senses. It has to be correct alphabetically, it has to be correct lexically, syntactically, semantically. So a programmer can also make mistakes with each of the above four senses. That's why you can always have bugs in programs. So let's assume you are successfully using a program. How do we persuade the computer to execute it? You have to render your program into machine language. Luckily, the translation can be done by computer itself, making the whole process fast and efficient. So compilation now, the source program is translated once. However, this act must be repeated each time you modify the source code by getting a file, right? So for example, you now see .exe on system. When you want to install, you go and download vlc.exe. So that file, now when you install it, you don't need to have the compiler to be processed. Just install that and you're going to run the VLC. Then there's also interpretation. Now, interpretation means that you can translate the source program. Remember what I said source file is and what source code is. So you're interpreting this what source code now. Each time it has to be what run. So the computer performing this kind of transformation is called the interpreter. So, and as the interpreter interprets every code every time, interprets the code, is for the code to run, it has to be interpreted every time, rather. Right? So as it interprets the code every time it is intended to be executed, it also means that you cannot just distribute the source code as is. For example, you carry a Python file and send it to another person. If the person does not have a Python interpreter installed on his laptop, he cannot understand your Python file. He will not be able to use a Python file for anything. So that's the difference. So there are very few languages that can be both compiled and interpreted. Usually a programming language is protected with this factor. So will it be compiled or will it be interpreted? So what does the interpreter actually do? So the computer, let's assume you have written the program, all right? So you now have the source code inside the source file. So and that is existing in as a computer file, right? So a computer program is actually a set of, actually a piece of text, which I call the source file. So the source code is usually placed inside the text file, which is called the source file, all right? Now it has, remember that it has to be what pure text without any decorations like font color, embedded images, other media. Now you have to invoke the interpreter to let it read your source file. So the interpreter reads the source code in a way that is common in Western culture. So it reads from top to bottom, from top left to top right, then the next line, line by line. So that's how interpretation is being done. So first of all, the interpreter checks if all subsequent lines are correct. And if the interpreter finds error, it finishes the work immediately and the only result that shows is what the error message. So the interpreter will inform you where the error is located and what caused the error. However, these messages may be misleading as the interpreter isn't able to follow such intentions and may detect some distance from their real cause. So We are going to look at that when we start running long Python codes. You still have Python is going to be going from line to line. It will not go back. Sometimes it might be required to go back up again and go and run a loop. When you call a function, to go back and call that function, now come back to where it was before and resume and give you a desired result. So, but if the line now looks good, the interpreter finishes up the program and gives you the desired results that that source file is supposed to give you. So you may now ask, which is better, compiling or interpretation mode? Is compiling better than interpretation? Yes or no? Let's look at the advantages and disadvantages. Now, for compilation, the execution of the translated code is usually faster. All right. Only the users that have the compiler, only the user has to have the compiler. The end user may not need the compiler before he can use the code. So the translated code is stored using machine language, as it is very hard to understand. Your own inventions and programs are likely to remain your secrets. But the disadvantage of compilation is this: the compilation itself may be a very time-consuming process. Before an application compiles, if you know how apps are being built, they are being compiled. All these Android applications, they are being compiled. So that compilation, that process of compilation might be very, very long. It can take hours, depending on the performance of your system. All right, and you have to have as many compiler as hardware platforms you want your code to be able to run on. For example, when making an application, when you're making for Android, it's not the same app that you compile for Android that you compile for iOS. Are you understanding? So if you want to, you have to have a different compiler to be able to compile for what iOS. Now, on the interpretation end, you can run the code as soon as you complete it. There's no additional place. So the code is stored using programming languages, not machine code. So this means that it can be run on computers using different machine languages. You don't have to compile your code separately for each different architecture, which means that for every system, whether MacBook, whether Linux, whether Windows operating system, whether Ubuntu, Red Hat, as long as they have Python installed, they can run your code. But now, disadvantage is this: don't expect that interpretation will ramp your code to high speed. Your code will share the computer's power with the interpreter so that they can be really fast. Both you and your end user have to have the interpreter to run your code. So let's jump into why we're here, Python. Python was coined from an old BBC television comedy series called Monty Python's Flying Cruise. So it's rather for you to just know the history of Python. All those things, you can read them on the course. All right. So, but who created Python? The person that created Python was Guido van Rossum, and he was born in 1956, right, in Haarlem, the Netherlands. And it's good for you to know that Guido van Rossum did not develop and evolve all the Python components by himself. So Python was actually open source, all right, and we had many users. We had many users or many programmers come and contribute to the open source project. Now, when you're doing projects, all right, there's open source, there's closed source. So when something is open source, it means that anyone can contribute to its development. So different people can just come together. Let's say you are creating a website. You now say, okay, this website is to communicate the goal of the website, and you just have people come in and say, okay, I can do this part. They come and contribute. They do it and they do their bit and they go. That's what open source is. That was how ChatGPT came about. Open AI. So it was an open source project. Okay. But when it is closed source, it means that only you. Says that an example is like iOS or Mac. You find out that everything in iOS is restricted. All right. Their applications, you don't know how they are being built. You don't know the architecture behind. All right. Up to today, you might not even know the chips that are running inside your iPhone. Okay. So that's because Apple was closed source. So look at here, it says The circumstances in which Python was created are a bit puzzling. According to Guido van Rossum, said in December 1989, I was looking for a hobby programming project that would keep me occupied during the week. My office would be closed. I had a home computer and not much else on my hands. I decided to write an interpreter for the new scripting language I had been thinking about lately, a descendant of ABC that would appear to Unix or C hackers. I chose Python as a working title for the project, being in a slightly irreverent mood and a big fan of Monty Python's flying circus. So that was just how Python came about. So what else makes Python special? It is easy to learn, easy to teach, easy to use, easy to understand, and easy to obtain, install, and deploy. All right, so Python has two rivals majorly, which is Perl and Ruby. So these are two other scripting languages. Perl was authored by Larry Wall. Ruby was authored by Yukihiro Matsumoto. All right, so but where can we see Python in action? So Python is very versatile. You can use Python in many things. All right, you can use Python in machine learning, AI, app development, web development, natural language processing, data analytics. Okay, Python is very, very versatile. So many developing tools are implemented in Python more and more every day. Everyday use of applications are being written in Python. So lots of scientists have abandoned expensive proprietary tools and switched to Python. So lots of IT projects, testers have started using Python to carry out stable test procedures. So despite Python growing popularity, there are still some niches where Python is absent. Now, low-level programming, sometimes called close-to metal programming. So if you want to implement an extremely effective driver or graphical engine, you wouldn't use Python. What they are trying to explain here for us is this is where people like NVIDIA come in, that produce the graphics card. Those are close to meta programming, where they use really use zeros and ones. If you go and research on NVIDIA and you go and see how they do produce their graphics cards, if you see the amount of chips that are inside, if you see the complexities of how NVIDIA graphics cards usually process images, those are, you see that when they say close to meta, it's really close to meta because they are very, very, very intricate. So applications for mobile devices. So although the territory is still waiting to be conquered by Python, it will most likely happen someday. For now, Python is not mostly used for mobile devices to produce mobile applications, right? Although you can use it, but you won't be able to do much with it in building mobile apps. So there's more than one Python, right? We know Python, there's Python 2 and there's Python 3. Now the 2 and there's Python 2.0. So it's all started from 0. So Python 2.0 is the older version of the original Python. Then Python 3 is an evolved version of Python. So Python 3 is what is invoked now. Python 3 has stopped. Python 2 actually, they've stopped developing Python 2. They stopped contributing to the Python 2 project. So it's only Python 3 now that is being worked on. So if you're going to be building any project, you have to use Python 3. All right. So the two of them are still Python. We can understand both of them, only that they just have very few differences in their syntax. All right. Sometimes when you want to write in Python 2, now you want to write the print statement, you might not use to put brackets. For Python 3, now you must put brackets when you're using the print statement or the print English function. So if you are going to start a new Python project, you should use Python 3. And this is the version of Python that will be used during this course. It's also important for you to know that the good news that all the newer version of Python 3 are about compatible. Now, yes, Python 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. So that those are different versions of Python 3. All right, so you might say Python 3.4.1, 4.2, 4.3. Those are different versions of Python 3. So the good part is that Python 3 is backward compatible. It says that Python 3.7 can run Python 3.6 code. It can also run Python 3.4 code. It can also run Python 3.1 code and Python 3.0 code. That's because what Python 3 is what backward compatible. That's what it means to be backward compatible. All right. Then it's important for you to also know what C Python is. But first of all, there are Pythons which are maintained by people gathered around the Python Software Foundation. All right, a community that aims to develop, improve, expand, and popularize this environment. So the PSF president is Guido van Rossum himself. And for this Python is called what canonical. They are also considered to be reference Pythons, all right, as any other implementation of the language should follow all standards established by the what? Python Software Foundation. So Guido van Rossum actually used the C programming language to implement the very first version of Python, all right. And this decision is still in force. All Pythons coming from the Python Software Foundation are written in the C language. Are you saying? So what was used to build Python was the programming language C. So it was C only evolved to become Python so that it is much more user-friendly and easy to understand by humans. That's why you find it easy to understand Python. And you should know that Python languages can be converted into C. When you write a Python code, you can convert it into C. So this is why the Python software implementation is often referred to as what? C Python. So Python is also C Python. That's because you can convert Python to C. So C Python or Cython is one of a possible number of solutions that are most painful to the most painful Python scripts. For example, now when you want to write a complex mathematical calculation in C, it could be very, very tedious. But you can write it in Python, all right, and then run it on C. Okay, so you can write it in Python and now convert. As long as it's running in Python, you can now convert that Python code to C, and it's going to run much faster because C is actually faster in compilation than Python or in interpretation than Python. So this is what Cython is intended to do. It automatically translates the Python code, which is Python code. Remember, Python code is built for you to be able to understand. Python was you can be able to understand and write your code better, more expressively. So Python was clean and clear, but not so sweet. But C, on the other hand, was kind of complicated and talkative, but agile. It says that C was a much more powerful programming language. So there's also JSON, and the J here is server. So imagine a Python written in Java instead of C. So this is useful, for example, if you develop a large complex system written entirely in Java, you want to add some Python flexibility to them. So the traditional C Python may be very difficult to integrate into your Java program. Okay, so this is where the JSON comes in. You can write in JSON and communicate with the Java infrastructure much more effectively. So the current JSON implementation follows the Python 2 standard. So there's no JSON conforming to Python 3 so far. So there's just so little you can. So there's also something called PyPy. So this is just to depict Python in Python. All right, so a Python within a Python. In other words, represents a Python environment written in Python-like language named with RPython, restricted Python. So the source code of PyPy is not run in the interpretation manner, but it's instead translated into C programming language and then executed separately. So this is useful because if you want to test any new feature that may be introduced into mainstream Python implementation, it's easier to take with PyPy than what with C Python. So there are others actually, apart from C Python, there are others. If you go and do research, find out that you see more different kinds of Python. But the normal Python that you know, Python programming, the popular one, the most popular one which you have been hearing about, is what C Python, although we just call it. Now, this is where we have to do a little bit of practical. I'm just going to show you how to set up. Let me stop presenting. I'm going to show you how to set up your Python environment for those of you that want to set up the Python environment. So let me present my screen. So if you download Python, from internet, all right. So if you search Python on Google, you're just going to, it's going to take you straight to python.org. And when you want to download, you can see the latest now. The latest was Python 13.3. So if you just click on this, it's supposed to download right away. But if you come to download here, you're going to see other versions, right? So you can see Python 3.14. Now, Python 3 version 3.14 is already out, but it's now is in what pre-release status, meaning that it's still under building. All right, they are still processing it, they are still building it. Okay, although you can install it and try it, if you want to be part of, you want to contribute to the code. So when you try some kind of code, you can now report to the Python community. That is what you notice with like Python 3.14. That's another way to contribute to open source projects. All right, so there, but there's 3.13. You can see other versions here. So these other versions here are stable already. Okay, so you can see 3.13.2. It was released when February 4, 2025. 3.12, it was updated again. 12.9, it was updated again this year. You see other versions here. So depending on the version you want, you can just choose anyone to download. But since 3.1, 3.3 is already stable, you can download that here. And once you download it, you just install. You know how to do that. I think I might just create a virtual machine and a Windows virtual machine and show you how to install that there on that virtual machine. For those of you that will want, you don't necessarily need to install Python. You can also just use it on your Cisco NetAcad platform. The next thing I'm going to show you is how to, if you're using the VS Code IDE, right? So I'm going to open up my VS Code. So this is my VS Code. So if you install VS Code for the first time, when you open it, this is what you're going to see. All right. You're going to see this. And before you can actually write a Python code, let me see if I can make things bigger. Okay, so this is better. So if you want to write a Python code first, you have to install an interpreter to VS Code. So you just need to come to VS Code is Visual Studio Code. All right, so if you come to extensions, and you can see here, I already have Python installed. If you just search Python, same for other programming languages, apart from HTML and CSS. So you can see Python, this is the official one for Microsoft. All right. So this is the Python interpreter that works with VS Code. So once we have this installed, you can be able to interpret the VS Code will understand your Python codes that you're writing or program that you're writing. So coming back to here, I'm not going to create a repository. I'm just going to go back to so I'm going to open a project. Now, when you're programming, all right, this is just a bonus. When you're programming, okay, it's good to create folders and work with folders. All right. So I'm going to share my entire screen so that you can see my pop-ups. All right, so my entire screen is being shared now. So if I should click on open folder, I have folders, all right, here. For example, these are my GitHub. You can see these are different Python or different projects. Now, folders in Python or folders in programming are called projects. All right, so if you want to open a project, no, I want to open this folder as a project, Python fresh. Select folder. Now it's going to open up. Different Python files that I have here that I did a long time ago. So right here, I have a dice rolling simulator, right? I have a dice rolling simulator so that when I roll the dice, different results are going to come out. So if I wanted to run this now, I'll just click on run Python file. And this is my console, all right? This is my console. This one that you're seeing here, this space you're seeing here. So you can see it says what the program is saying what enter Y. Once I click on enter, the result it means that it's going to roll my dice. So what's the result of my die? My rolling of dice, right? 1 and 3. So yeah, what appears 1 and what 3. If I roll again, I have 5 and 1. So I have 5, 1. If I roll again, 2 and 2. So I just rolled for doubles, 4 and 1, just like that, 4 and 5. Now you can see there's no 4 and 5 here because I've not in the code, I've not actually done that. So these are just, I'm just showing you all this just so you don't get distracted. Let's go back to, let's close this particular folder. So I'm going to actually open a new one. Let me go to file. Now open folder. So I can create a new folder here. Let's say new folder. Let's call this safe house. So I'm going to create this folder and click on select folder. Now it's open. We have an empty blank folder. That's because in my documents where I have the cyber safe house, the folder is actually empty. So you notice that, let me just open this here. And if I come here and I click on create a new Python file. So if you want to create a new Python file, all right, every Python file you're creating should end with .py. For example, hello world is not good. Don't always use space bar to name your files. Always use hyphen, right, or underscore. So hello world .py is what makes it a Python file. So you can see now, because I put .py, the icon here has changed to Python. So you can see it's no longer, it has changed again. So I should add .py. You can see now VS Code understands that it was a Python file, which means that when I open it, I have a copilot here. So, sorry. How do I close this?
Sorry, I'm lost though.
Yeah. Where did you lose me?
Okay, are you using this interface you're using now? Is it VS Code or Python?
Yes.
No, you
Yes.
just told us
VS
to
Code.
download Python.
Yeah, I told you to download Python. I'm also showing you how to set up your VS Code if you have VS Code or if you want to use VS Code to run different projects. And I was telling you that there's no need for you to do that because if you're just going through the course, you can see the course has an inbuilt IDE inside integration. It has an IDE inside, right? For example, let me show you. I showed you previously. This is variable. So this is an IDE here, right? Where you can type something.
Okay, integrated development environment.
Yeah, integrated development environment. That's right. So you can see this is an inbuilt IDE where you can type something. You understand? And you can
Yes.
run the code. Yeah. So I'm saying that if you want to, for example, now look at this. I can actually download this file. You can see now my browser is going to ask me this file could harm me. That's security, right? Do I want to? If I click on keep, so you can see main.py. This is a what Python file. That's how you know it's a Python file. It's .py. If I should come to my downloads, so you can see main.py here, right? And I can choose to open a VS Code. Let me cut it and put it inside my Python folder that I just created. So remember, I created hello world inside VS Code. Let me paste it, main.py. So now if I should come back to my VS Code, you see main.py there. And you can see that exact same thing that we saw within this Python code here is what we have inside the file. Exactly.
Yes, yes, I understand now. Thank you.
All right, good. So, not to take us far, I'm going to delete this. So this is hello world, and the very first thing we will always print in Python is print hello world. So we use the inbuilt function, which is print, written in capital letter, open bracket, and say print the string hello world. So now, if I should run this code, it's going to print out hello world. So there we go. So that's how the print function works. And if I should change this to capital letter P, now the good thing about using an ID or an external ID is that while you are typing, it can be helping you do recommendation. If I say print, before I even type it, you can see print as a click on tab. It's going to, you can see if I again, it's going to help me write everything out without me having to type so much, right? But if I was using this inbuilt IDE here, let's see, you can see print. Forget about this. This stuff is my system. I set it up by myself. Print. You can see it's not helping me do anything. I have to type everything by myself. Hello world. So when I run this code, you can see it does this. Right. So this is side module 1. This is side module 2. We're still in module 1. So I've showed everybody, I've showed how to install Python, how to download it, how to install it and run it on your system already. So you can just go ahead and take the module 1 quiz or the module 1 test. So it's only about 10 questions, right? So that shouldn't take anybody time. But jumping to module 2, which we're talking about the very first writing the very first program, which I demonstrated with Cisco print hello world. Now we have hello world printed. So now the print function, the word print, okay, is what a function name is, an inbuilt function in Python. All right. It doesn't mean that wherever the word appears is always a function name. All right. So the meaning of the word comes from the context in which the word has been used. So when a function in Python now, okay, means something that is going to cause an effect or evaluate a value. So you can see here, cause and effect, for example, something, all right, print, create something, draw something, do something, play something, or play a sound, or evaluate a value, add something, join something together, perform a square root, count something, all right? So that's what the print function. So where do functions come from? Functions come from Python itself, all right? So those are what built-in functions. The functions that come from Python, they are what built-in functions. For example, the print is a built-in function. We're going to see those things later in the course. They come from modules. So Python has add-ons modules, right, that are in Python that you can import. All right, so those become functions that you can use inside Python. Later in the course, we're going to see how to use different modules. Okay. So you can also write functions by yourself. For example, when you want to calculate the area of rate. So for the next time you want to now calculate the area of another rectangle, instead of going to type start calculating it again, you just write a function to be able to carry out that calculation. And when next you want to calculate area again, you just call that same function. Let's, for example, we create a function and call the function area. All right, we're going to get to all those parts where you see how to use all these things. Create a function called area. So the next time you want to find the area of something, we just call area of, you now put whatever size you want to put, and the function is automatically what give you results. So functions now may have arguments. All right. So these arguments, right, can be what will of the function, or what will determine the result or the output of the function. So remember I said that Python, the functions always have what an effect, or give an effect, or give a result. You can print something, you can say something, you can play a sound. So in spite of the number of needed provider unit, Python functions strongly demand presence of a pair of what parentheses. So whenever you are using a Python function, you must have what this parentheses. Now parentheses is different from brackets. Just so you know, what you call square brackets, that is brackets, but these curved ones are called parentheses, so that we don't misplace words. All right, so another thing you need to know is strings. So strings are any data at all that are enclosed in quotations. Okay, any data at all that is enclosed in what quotation. Let's look at this now. When we now say print hello world, all right, function name is what? Print, right? We have function name. The function name here is what? Print. And what's the argument? The string hello world. This is a lab, you have to carry that out. So we're just going to continue. Or let's see this. Let's see this lab. They say what? Use the print function to print the hello world on the screen. Use double quotes around the string. Having done that, use the print function again, but this time around, print your first name. So that's just us telling us to use what is here, and print it. Then the next time around, you just put your name. You can see my name comes out. So you can also use, now you can see here is double quotes that is here, right? I'm going to show us something quickly. If you don't put any quotes, Python is going to ask you for what this thing is, and it's going to give you an error. So if you do this, you can see the name raw is not defined. So Python will be looking at this as a variable, meaning that it's not looking like a container that has something inside, but now we have not defined it. So we're going to come back to that later. So when you're writing a string, you can either use double quotes or you can use single quotes. So, and always ensure that you close the string. All right. So if I should remove this, now you can see that this second, the closing bracket has become green, meaning that Python is expecting more part of the string. But by the time I close it, Python will tell you that, Python will now understand that, okay, this is the end of the string. And when it prints, it's going to, it says this. So when it prints, it's going to have what? Raw. So I can still use the double quote and it's going to give me the same result. So anytime you get stuck, you can always look at sample solution and you can see that Python has given you all this. So yeah, if you want to run this one, you just need to remove this hashtag here. Hashtag is what makes it comment. All right. And when you run it, you can see Greg appears. I'll come back to comments later on in the course. So now I've already explained what the print function does, what the argument does inside, right? So what if we want to write something very long, right? So you can see here, it says the itsy bitsy spider climbed up the water spot. All right. When we run this, it's going to print our answer, right? Everybody should know this already by now because the string opens here and it closes here. Let's go to our VS Code. I'm going to show you something. Now, if I was to write it's my pen, what do you think this will result? Now, remember, I'm using a single quote for my string, right? So if I'm writing it's my pen, right, as my answer, as my Python code. So I want to print it's my pen. So if I should run this code now, I'm going to get an error. Why? Because Python thinks that I closed my string here and I opened another string here. So Python is expecting me to what? Close this particular string. So that's what Python first of all noticed. And as they say now, unterminated string literal. You can see it here. Unterminated what? String literal. So Python is expecting me to what? Close this string. So even if I close this string, I'm still going to have another error because Python is not seeing this one as a string. But now when you want to write something that has an apostrophe, because Python sees an apostrophe as a quote, because they're actually looking like the same thing. It's actually the same symbol or the same key on your keyboard that types it. So they look alike. So instead of you doing this, you can either use double quotes and you close this here, double quotes. And if I should run this now, okay, sorry, I used capital letter, so it's the small letter. So you can see now it's right, it gives my result, it was my pen. Another way, if I wanted to insist and say I must use single quotes, what I can now do is to tell Python to ignore this quote that is here by using the backslash. So when I use the backslash key, Python automatically changes this to yellow. So you can see this backslash means that ignore the next character that is here if it was supposed to be something that is relating to an argument inside the function. So when I now print this now, you see that it's going to give me my results. You can see it's my pen. That's what the backslash does. Let's go back to our course. So we can also use, there's something called the new line. So if you want to start a new line, all you just need to do is what? Use the backslash and you type n. All right. You type n and the backslash before the n, and Python prints what? The itsy bitsy spider. Then goes to the next line and prints what? Climbed up the water spout. So when I run this one here, this print statement here is just going to give me an empty line print statement. So you see a space. So you can see now what I said, you see itsy spider now, the new line. This is where this guy comes into play. It takes the next output to the next line, climbed up the water spout. But then we have an escape character, which is a print that has nothing, no argument inside. So it's just like you're printing empty. So you just have that empty space there, and on a new line, have the next item. Down came the rain and washed the spider out. I think that makes sense. I already explained what this does. Now, what if you wanted to add multiple arguments? So multiple arguments in the sense that you are adding different items inside quotes. All right, so you can see the itsy bitsy spider. You also have what climbed up as on its own. You have what water spouts on its own. When you run this, you see that what it's going to print as one line. The same thing here. My name is Python is going to be on one line, and Monty Python is going to be on another line. Right? And please, just for knowledge sake, the full stop is not outside the quotes. It is what inside the quotes, because it is part of what the string, not outside. You don't put full stop here. Python will think it's something else. If you run the code, it's going to give you an error. So the full stop comes inside it. Now, there's another keyword argument you need to know that can work with the print statement, which is what the end. In our next class, I don't think I'll be doing directly from the course. I will just using VS Code directly so that it's faster instead of having pages to be loaded like this. So we have the end. So this end now means that after you print this thing out, okay, the end of it, what's going to happen is that it's going to be space. You can see there's a space bar inside. Normally, by default, what is there is what's supposed to be here normally. By default, this is what's there. In default, that's why when you print have two print statements, the next print statement enters the next line, because by default, the end of a print statement is what? A new line. But now, you want it to be space. When you run this, you see that both of them will enter the same line. You see. But let me reset this. By default, we have a backslash n, and we can see how a normal Python code writes. So if you don't put this keyword argument here, it's going to have the same results. But by the time you add a keyword argument, you can choose to separate it by something else. So I can choose to put, and let me reset this and run my code. So you can see now, you can see the plus here. If I put plus spacebar, run my code again, you see, we now have space here. But guess what? There's no space here. So if I wanted to add enough space, I have to put the space there. So you see the difference. Are you seeing? All right, then you already know what this result. There's no space bar here, which means it's going to join everything together, right? But there's a space here. Take note. After is, there's a space. So you're going to have your normal text. Assuming there was no space inside here, and I run the code, because you didn't put space here, it's going to join, this multi-Python is going to join with is, and you have, you see now, me, this is what I was avoiding. That's why I was not sharing my entire screen. So we have this. Another thing that we can know is what? Another keyword argument is what? The separation. Normally, by default, all right, there's no separation. So now we will now put this dash, right? You can see now, instead of what we're having here is what? As a separation is what? The hyphen. We're having hyphen as separation. But what if we remove this separation from here? And I run this code. Let me remove the separation and I run the code. You see, the normal separation is what? Space bar. But by the time I set this, if I should use plus, it means that the separation will no longer, by default, it's supposed to be space bar. If I remove use plus, my separation will become what? Plus. If I should add space between the plus and I run it, you see, we are going to have space there. So you can actually use those two keyword arguments together. All right. So that's why we have, you now use separation as asterisk, separation as new line. You're going to have Monty, then the next line, Python. But after that, you're going to still use C asterisk. All right, look at this now. Okay, so I think it's the network thing. All right, so now look at this. We have, for the first one, we have separation to be underscore. And at the end, we have what? This. So my name is, for this particular my name is, we have what? Separation between these two things as well, underscore. And at the end, we have what? The asterisk. So which means this one is going to come to the next place. And we have Monty separated from Python with what? Asterisk. And at the end, we have new line. Now, why we're going to have new line is because why we have new line here means that if we print another thing, it's going to enter into the next line and say the end. Let me use double quotes. I'm going to reset this, run this. You see the end is going to come under. All right, so I'm going to be rounding up the session in the next 15 minutes so that we can call it a day. All right, we can still see my screen, right? Yes, sir. All right. So to explain this, so we're supposed to come to this. So this is another lab for you to carry out. So they say modify the first line of the code in the editor using the separation to match the expected output. Use the two print functions in the editor. Do not change anything in the second print. So you're just to add, they say you should add something to make this print what programming essential. So which means sep is equal to, we have asterisk, 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 right? Remember how it's being done. And we have end is equal to what? We have dot, dot, dot. So remember, this is the end of the first line, all right? And Python is coming in the next. That's when we print our results, it's going to give us this. We have an error. What's happening? Okay, sorry, I didn't add my comma there. So we're going to get the same thing here. So this was O, and we have gotten it, right? So that's just the solution to that lab. So you can see if you get stuck, you can see the solution there. Once you click on that, it's going to appear. All right, so this is a very quick lab that you can do just to make sure you print this out. And this is a quick solution. You're going to have this arrow. So it's going to take our time to actually look at it. So there's a quiz here for you to do. So quickly, we are going to run through this. I don't think this one's supposed to take our time. So there are literals in Python, all right? So the literals are the data in Python. So we have integers, all right? So we have integers in Python. So integers are numbers. Integers are different from strings, okay? For example, this 2 is a string. It is not an integer. When it's an integer, there's no quote there. For example, if you print this, you're going to get the same result, 2 and 2. But now, in integers, you can, let's just keep going. Instead of me to integers, that we have integers, we have floating points, and we have integers. All right. So floating points are numbers that have decimals. All right. So also for you to note that if you wanted to write the number 11,111,111, if you took a pencil to your right hand, now you will write what? 11, 11, 111, 1, 11, 111, 111, right? Or you can use decimal to separate them, or you can use space to separate them. But in Python, it is prohibited for you to write numbers like this and use comma to separate them. You just have to type them straight up. And you can also use what? Underscore to separate them. They say, and how do we code negative numbers in Python? So you can do that by adding what? Minus them. So take notes in Python when you want to use, for you to know that you're writing 1,000. Normally you, but in Python you don't use comma, you use what? On. So there are also hexadecimal numbers. There are octet numbers, all right, or octal numbers in Python. So this is an example. So you can see when you write a number in octave, so octa is actually what base 8. So this number here is what base 8. So Python automatically gives you the answer in what base 10, which is what 291. So then to float, we have 2.5. 2.5 is a float. So minus 0.4 is a float. As long as it has a decimal point, it's what a float. Now in Python, when you write 0.4, Python will not type 0.4 for you as a result. It will put what 0.4. Another one, 4 in Python will be written as what? It will not add the 0 for you. When you are printing your result, that's what Python is going to give you. But let's compare integers and floats. So 4 is an integer, right? Why 4.0 is a floating point. Now, they mean two different things in Python. Python does not see them as the same thing. Python sees this one as 4 and sees this one as what? Floating point. It's you now as a human being that you know that two of them are the same thing, that two of them are equal. But Python sees them as two different things in the sense that one is what integer and the other one is float. So when you're now multiplying and or performing arithmetic operations in Python, all right, the letter E. Okay, let's continue from here first of all. It's not only points that it floats, all right? You can also use the letter E. So when you want to use any numbers that are very large or very small, you can use scientific notation. So for example now, the speed of light is what? 3 times 10 raised to the power 8, right? That's 3 with what? 8 zeros. So you still have to write this long thing, and instead of to write 3 times 10 raised to the power 8, what you write is what? 3E8. 3E8. So 3E8 in Python means what? 3 times 10 raised to the power what? 8. 3 with what? 8 zeros. That's 30 million, right? I mean 30 billion. Yeah, so that's 30 million. Sorry, 300 million. So we have coding floats. In coding floats now, all right. So Python is going to give you can do 6.6 times 6.6e raised power minus 34. So this now is an example of an exponent in Python. All right. So if you wanted to write this in Python, what you write is what? 6.62607 e minus what? 34. So if you printed this in Python, Python will give you this as a result. So look at this now. Let's copy this. There's no nearby. Okay, this is a nearby. So if I should print this, so you can see now it has given us what? 1e minus what? 22. Now strings. Strings are enclosed in what? Quotes. I already explained that earlier. Strings are enclosed in quotes. And when you want to ignore a quote, you use what? The backslash. So the backslash, Python, when you put a backslash in your code, Python understands that it's going to what? Ignore the next character. It's going to treat the next character as a string. It's not going to treat it as the closing of the string or whatever you want to put there. So this now, let me read. So this now, example, I am multi-Python. This is going to what? Cancel this closing quote back and what? Create what? I'm multi-Python. I already explained this here. So booleans, there are booleans in Python. All right. Booleans have Boolean algebra right, have two outputs, which is either what true or. So true is the same thing as 1, false is the same thing as 0. This is a language that computer understands. Computer understands what 0 and 1, true, false or true, 1 and 0, true or false. So Python then is a what binary reptile. So these two Boolean values have strict denotations in Python. So for example, now you want to check, is true greater than false or is true less than false? The answer is either what true or false. So if I should put this here, is true greater than false? Yes or no? Is 1 greater than? Remember, true is what 1 and false is what 0. Is 1 greater than 0? True. So the first answer should be what? True. Is true less than false? False. The answer of the next one should be what? False. All right. You can see true and what? False. So that's so Python as a calculator. This is where I was going to come. I didn't want to jump so that you can see the difference for yourself. So you can see here, Python is seeing 2 plus 2. Remember, it's not a string. If I should paste this thing here and run, 2 plus 2 is what? 4. Now, what if I made this thing to be a string, 1 to be a string, and the other one to be an integer? Remember, what makes it a string is what it puts. So if I should print this, you have what? You can see, can only concatenate what? String, not integer. Do you see? You cannot add a string to an integer, but I can add 2 strings together. For example, 2 and 2. If I should run this, it's not going to give me 4. Them are not integers. What it's going to give me is what? 2 to 22. Look at this. Do you see? This is going to give me a different answer than when I had what? 2 plus 2. This is what? 4. So we have basic operators. We have plus, minus. Asterisk is what? Times. So when you want to multiply something by another thing, you have to use what? The asterisk. When you want to divide, you use the forward slash. Now, there's still another one. This double slash means that it's going to just give you what? The integer. It's going to give you your result as an integer and leave the decimal out of it. Then this percentage sign is called the modulus. It gives you what? The remainder. So if you want to know 6 divided by 2, what is the remainder? You say 6 modulus 2, and it will give you your answer. Then double asterisk is what? Raised to power. When you want to do raised to power something, raised to power 2. Okay, now this is where I was coming that time. 2 raised to power 3 is what? 8. 2 asterisk 3 is what? 8. 2 asterisk 3.0. Now this is an integer, this is an integer, but this time around this is an integer. The second one there is a float because it has what? Decimal point. When you use a float and an integer to perform an arithmetic operation, the answer or the result is always a what? Float. We also see another example here. When you have a float first and an integer second, the result will give you what? A float. But when you have 2 floats, the result will still give you what? A float. Now, let me prove it. So you can see the first one, 2 raised to power 3 is what? 8. 2 raised to power 3.0. Remember, this is same thing as having 3.0 is what? 8.0. 2.0 raised to power what? 3 is what? 8.0. 2.0 raised to power what? 3.0. Let's add 0 so that you see that it's the same thing. So you can see the same results. All right. So whether you once you put your decimal point, it does not matter. As long as it's 0, you don't need to put the 0 for Python to understand that there's a 0 there. Just like there, you say there's a invisible plus. But when you want to have the negative value now, you now put your minus there. So the same thing with multiplication, right? 2 times 3 is what? 6. 2 times 3.0 is what? 6.0. You can see. Once you're using float, and the same thing with your division. Now, integer division. This now is going to give you your answer as an integer. It's not going to give you answer as a float because you're using what? Double slash or double division sign. So 6 divided by 3 will give you 2. 6 divided by 3.0 will give you what? 2. It's not going to add the float to it. All right. So, okay. So I was even wrong step. As long as you're using your float, it's going to give you an answer in float. But this time around, if there's a remainder, it's not going to give you the remainder. So let's assume this was 8. Let's use this so I understand what is happening. So you can see 8 divided by what? 3 is what? 6. But actually, there's supposed to be what? Remainder 2, right? For the second answer, there's remainder 2. But it's not going to give you the remainder. It's just going to give you what? The result as an what? As a whole number. Okay. Let's go to the next one. Okay, same result. Now when you're having multiple, this is going to obey your normal minus divided by minus, minus divided by plus rule, and you're going to have negative, right? So the next one is what? Modulo. 14 divided by 4. 14 divided by 4. Is there a remainder? Yes, there's a remainder. 2. Because normally 14 divided by 4 is what? Are we there? Are we there? So 14 divided by 4 normally is 3, right?
Yes.
And
Yes.
all right. So 14 divided by 4 normally is 3, right? But then it will have remainder what? 2. That's what this model does. So it just gives you the remainder and leaves out the integer part of your arithmetic operation. So imagine you're writing a code. If the remainder, if this in this and it has a remainder of 2, so you perform this action. That's when you use. That's where this particular arithmetic operation is very, very important. So how about we do this? So you see, it says here that 12 divided by 4.5 gives what? 2.0. 2.0 times 4.5 is what? 9.0. 12 minus 9.0 is what? 3.0. Those are other examples. If you are using plus, the answer is going to be in float also. So you can result is in float because we have 4.0 minus 4.0 plus 8 are normal arithmetic operations. Same thing with this one. So operators and their priorities. All right. So every operator has its own priority. All right. You probably remember normal school, normal board maths, right? Multiplication precedes addition. The same way in Python. So you surely remember that you should first what? Multiply 3 by 5 and keeping the 15 in your memory and add that was 15 to what? 2. So the phenomenon that causes some operators to act before others is known as what? The hierarchy of priorities. So if you know that multiplication has higher priority than addition, the completion or the final result should be what? Obvious. So if you are doing this now, 9 modulo 6 modulo 2. So 9 modulo 6 gives what? 3. And now 3 modulus 2 gives what? 1. So it starts from here. When you get your results, that result now modulus what? 2. The same way you have this. Let's run this code. What do you have? 200 and what? 56. So when you do 2 raised to power 2, which is 4, 4 raised to power 8 is what? 4 raised to power 3 rather is what? 64. But now, this time around, when you start from the left-hand side, all right, because now you're talking about raised to power. If you're writing this thing in normal, can I think I should be able to have a whiteboard here. So normally, if you wanted to write this thing, you write it as 2 raised to power what? 2 raised to power what? 3. So if you're going to perform this particular operation, you're going to actually have to do this one up first, and that result, you use it for this one down. So that's why you now do 2 raised to power 3 first, which is what? 8. Okay, which is exactly what the second answer is. You get 8. So now, you now say what? This one now is going to be equal to what? 2 raised to power what? 8. And then you have what? 256. I think that makes sense. Here is. Oops. There is something. So look at now. These are the priorities, right? Raised to power comes first, followed by normally unary operations. Okay. Now, unary operators located next to the right of the what? Power operator bind more strongly. So which means that if we had this 2 raised to power minus 2. So this is what they are calling unary. Okay, this particular minus now that is binding this one that is having the power. So this one has more power than what? Than this plus that you are going to have here, plus 3. This is binary. This is binary because this is only for the number itself. All right, but this one now is for it's going to affect both of them like this. Then the next in line is what? Multiplication, division, modulus, and integer division. Then we have our binary operation. So I think that's the end of this one. I think we can actually conclude this chapter 2 here. So once we are done with variables, comments are very short and call it a day because that's going to be the end of module. So now, variables in Python are like boxes that you put values inside. Remember variables in mathematics, they'll tell you finding x, what is the variable x? So x is actually a container that also have a value inside of it. So now, variables store data in Python. So what does every Python variable have? Every variable has what? A name and a what? Value. So the value is actually what? The content of the container. So there are variable names, rules in writing variable names in Python. All right. So one of it is that the name of the variable must be composed of uppercase or lowercase letters digits and characters and the character underscore. All right, so you can have that has it uppercase inside, lowercase inside, has a number inside, and also has a what underscore. You don't use hyphen for variable names. Okay, you don't use hyphen for variable names. Don't worry, we'll just understand that later. So the name of the variable must begin with a letter. You cannot start the name of a variable with what? A number. The underscore character is a letter. The upper and lower case letters are treated as different. All right, I'm going to explain all these things later. So for example now, Alice with capital letter A-L, the small letter L-I-C-E, and Alice with all capital are the same names, but they are treated as different variables in Python. Because Python sees, in Python, every character has an identity. So capital A is different from, so your normal capital A in Python has a different identity from the small letter A. So even the same thing as the capital E, it has a different identity from this. Another thing you need to know is that the name of the variable must not be any of Python's reserved words. So Python has reserved keywords. For example, print. You cannot use print as a variable name. You look at, we'll see all those keywords there. See the keywords there. You have false, none, true, and, as, assert, break, class. Every word that you see here, you cannot use them as a variable name in Python. You're going to have an error. Okay, so we can have, for more information, you can just go and read this particular style guide for Python, and it's going to give you more information about this variable name. All right. Now, this is how to write incorrect variable. T cannot be a variable name because it does not begin with a letter. A variable, 10T cannot be a variable name because it does not begin with a letter. Remember, the first rule is that it must what? Second rule is that it must begin with a what? Letter. Exclamation mark important cannot be a variable name because it does not begin with a letter. It's starting with an exclamation mark. Exclamation mark are not allowed in variable names. Exchange rate cannot be a variable name because it has space. A variable name must not contain space. Let's look at how to create variable. Now, to create a variable in Python, you write the variable name and you use the assign sign, which is the equal to sign, and you write what the value. So now you have put this number 1 inside the variable with var. So now if we now say print var, now you can see there's no quotes here, right? That's because this one now is defined. That's the 1. So anywhere Python sees var in your code, it's going to know that it's 1. So by the time you print this, you're going to have what? 1. But if I should go and put quotes inside, it's not going to print 1 again. It's going to treat it as a string, and Python is going to print what? var. So this is different from having var, because this is what, when you have your print statement without the quotation, Python sees this as what? A variable. And Python goes to the variable, searches your code, and now go and look for the value that it represents. So assuming this has not been defined earlier, you see that Python is going to give you an error telling you that var is not defined. So you can see the name var is not what? Defined, because it's a variable that has not been defined. But when you define it, Python is going to give you the results. Another one, you can say account balance. So you can say account balance is a variable name. Now, in place of spacebar now, you can see they use underscore. Underscore can be included inside a variable name. And now, the content of this variable is what? A float. The content of this variable is what? An integer. And we have another one, client name. The content is what? A string. And we can now say print var, comma, account balance, comma, client name. We are going to have what? 1, 1, then space 1000.0, then space the client's name. Let's run. You can see that John Doe. Then print var again, we have 1. Now, you see now, this example is going to cause an error because var here inside the print statement has capital letter V. Remember I said that letter V has different identity of small letter V. You see that Python is going to give us an error that VAR has not been defined. You can see VAR because it has capital letter V. Capital letter V is not defined. But now if I should define capital letter VAR and put what 2, and I print this result, you see that the answer is going to be what 2. Because now I have defined what VAR. And now I can ask Python. var equals var. Let's use is greater than var. Remember, VAR with small letter is what 1, and VAR with capital letter is 2. So is 1 greater than 2? Obviously not. So the answer will be what? False. But if I should say is 1 less than, obviously the answer will be what? True. So you can see now that var is different from what? var, because this var has capital letter V and the second one has small letter v. How to assign a new value to an already existing variable. Now, when you define a variable in Python, all right, you put var first for the first time and you assign 1 to it. If you define it again the second time, it's going to overwrite the former value of var. So now, remember I said that Python processes code from the top, all right, line after line. So Python will understand that var is what 1, and now prints what? Prints var. So Python is going to, the result now was print 1 first. All right. So after that, also was also expect 1. Then the next line, Python understand that var now is equal to what? Var plus 1. So Python is going to take the former value of var, which is 1, and add it to what? 1, which is what? 2. So now the new value of var is going to be what? 2. So when next we print var again, you're going to have what? 2. So our results were expecting what? 1 and 2. Does that make sense? You can use a reaction, I can see them. All right. So you can see here now, if you say var equals to 100, var equals to what? 200 plus 300, and you now want to print var. var is not going, the value of var is going to be what? The new var that you define, no longer this former one. All right. So this is going to give us what? 500. So you can see the answer is going to be what? 500. So you can also assign a mathematical problem to a variable. For example, now you put a raised to power 2 plus b raised to power 2, then the answer raised to power what? 0.5. This here is just the same thing as writing a raised to power 2 plus b raised to power 2, then both of them are inside brackets, and it's raised to power what? 0.5. So this is exactly what is. So now you need to make use of what? The raised power operator, the exponential operator, to evaluate the square root. As what? This Remember this is 0.5, right? 0.5 is what? The same thing as what? Raised to power 1/2 normally. So this 0.5 here, if we wanted to write this correctly, what we'll put here is what? 1/. And we know in the laws of indices that the square root of something is the same thing as what? That number raised to power what? 1/2. So we have c is equal to what? Square root of a raised to a squared plus what? B squared, which means we have what? Our final answer to be what? A squared B squared. And we have 4 plus 3. So now what we have here is that we don't have 5.0 as the answer. All right, so that's just some little math that we did there. Okay. So there's a lab here. You can try that out. So they are say they are shortcut operators. So I think you should click this on your own. So instead of you to write, normally if you wanted to write this x raised to power what? X times 2. X is equal to x times 2. You guys, that's what? X times equals to, or x asterisk equals to. So this thing you are saying here is the same thing as what you are saying here. Now, you want to write sheep is equals to what? Sheep plus 1. You can write sheep plus equals 1. So Python understands, what Python understands that this is what you are saying here. Later in the course, you see how all those things are being used. So these are some common shortcuts that you should look at. All right. Just compare them, understand them, understand. So that when next you see this kind of thing in the code, you understand that this is what it means. When you see something like this in a code, you understand that this is what it means. Then just do the last lab that's here and answer the questions. So the last thing we're looking at is comments. So in Python, there are just 2 ways to add comments. So you can beginning with a hashtag. So when you write hashtag, Python automatically ignores that particular line. So when you use a hashtag, Python ignores this particular line and does not process it as a code. All right, so as part of the program. So what comments are used? They are used for when you're writing a code or writing a program, use hashtags or use comments to write some stuff or explain things so that once another programmer is looking at your code, the programmer understands what you are trying to do in that code. So for example, now you can say hashtag, this program evaluates the what? Hypotenuse C. A and B are the length of the what? Leg. So you can see here now again, we use the asterisk instead of square root, right? So comments, you add comments just so that when another programmer is reading your code, they understand what you are trying to do. Okay. You also use comments to like stop some part of your code from processing. For example, you already have y is equal to y plus x. So but you don't want Python to process this. You just add it, hashtag there. Python automatically changes it to comment. All right, so I think that's all. That's all for comments. Interaction with user. We do this in the next 5 minutes. I think let's just leave it. I'm going to use VS Code to explain this in our next class. So let's call it a day here, right? So that you can go and rest for the day. So I hope you all understood and enjoyed this class.